Hello, welcome back to my channel and tutorials. I'm your sir here to guide you on with the syllabus of mathematics and many more. Of course, many more will be coming very soon. What we were doing last video, what we were doing? We were doing something like, remember this one? Last video, I think we started a new topic where I discussed some of the basic things of sets, remember? Okay, so let's continue with some more basics of sets. You remember I promised you something last class, that is like at the end of the video. If you watched the video till the end, I promised you something. Kya tha wo promise? What was the promise? It was like, okay, in the next video I will be discussing on the different kinds of sets and on different kinds of sets. So I'll keep up to my promise. I'll continue with those. But before we just jump into the different kinds of sets, let's do a little bit of rewind. What were sets? What did we study last class? Last video? Those who haven't, please go through that last video and then only come to this video so that there will be sequence. Otherwise, that sequence will be broken and you'll end up not really understanding things properly. Last video, okay, we understood what is a set, collection of well-defined objects, basically numbers and alphabets. Then of course we studied on how to represent sets in like two forms. One is the roster form, where we just write down the numbers and the elements. The other one is a set builder form, where we explain things in words and all, right? And how do we denote the number of elements? What are called members and elements of a particular set? Yeah, these were some of the things that we learned last class. Now today we're going to learn some different kinds of sets now. That is, the first one that we're going to study is empty sets. So the first kind of set that we're going to be studying is empty sets. Now what is an empty set? Very simple. Empty set is a set which is empty. Right. An empty set is a set which is empty. That means khali, which means here. It's going to be empty, it has to be empty. So how do you write an empty set? For example, like this. I give you one set builder form, okay? X belongs to natural numbers and x is less than 0. Okay. X belongs to natural numbers. So I'm telling you to basically write a set of natural numbers which are less than 0. Do we have? No. So we don't have any elements for that. So how shall we write? Khali, no element. So we're going to write empty. There's no element, isn't it? So there's no element in this set. So we're not going to write any elements. By mistake also 0 mat likh dena. Don't write 0, okay? Because 0, if you write, okay, now this is one element ho gaya na. 0 is also a number only, isn't it? So you just have to keep it empty. Or there is another notation that we use, phi. We call it phi. That is like this one, like this. So this is also one notation that is generally used to represent this empty set. But when you write this in this form, then again I repeat, no, that means within this set there is one element, isn't it? So don't do that, okay? Don't do that, okay? So either you write only this empty set which is empty, the set which is empty, or if you want to write on, then you will write only the notation. I hope you've got your pen, paper, as I always say, ready to choke down notes. Of course, you can always pause the video and then write on the notes. Second type of sets would be finite. So when I'm discussing about finite, simultaneously let's talk about infinite. These are just some basic sets, no? Finite, infinite sets. What are finite sets? Simple concept. That's why I have always mentioned English is very important in mathematics or being a science student. Finite sets, like those sets where the number of elements can be counted. Infinite sets, those sets where the number of elements cannot be counted. So they're called finite and infinite sets. So examples of finite sets like prime numbers up to 100. No, that's a finite set, right? Even like the population of people in this world. Chalo, that also we can count, so that's also a finite set. But when I say set of natural numbers, when I just say set of natural numbers, in the first instance, it's quite simple. Okay, I will start. I tell you, write down set of natural numbers. Okay, you start. Tell me that's not very difficult. No, 1, 2, 3, 4, 5, 6, 7. So where to stop? 8, 9, 10. I just told you to write down the set of natural numbers, so please tell me to stop. 11, 12, 13, 14, 15. So, sir, please tell me where do I stop? So I cannot stop, isn't it? Until unless I tell you, okay, stop at there. So this kind of sets are called infinite sets, no? Like set of natural numbers. So where do we stop? We have to just go on and on and on and on. But when I say, okay, write on a set of natural numbers up to 10, so we can put a pulley stop. No, we can just put a pulley stop there. So that's countable, isn't it? So any sets which are countable are called finite sets. Any sets which are not countable are called infinite sets. So that's quite simple, isn't it? Set of even numbers, set of multiples of 5, set of multiples of 3. These are all infinite sets. But when I say finite set, there should be a limit given to you, no? You go up to there, up to 100, you go up to 1000, you go up to 1 million. Still you can count and you can just stop there, isn't it? So these are called finite and infinite sets. Next, another important part would be number 4. Not exactly number 4, like just subsets. Subsets. What are subsets? Subsets are sub of sets. Subsets are subsets, substitutes, subsets, small branches of a set. That means you'll have a set and then you'll have small branches of a particular set. Those small branches are called subsets. Okay, subsets. So for example, if I give you a set A, 1, 2, 3, then this set, this set, this set, this set. See, these are all options which I can have, no? Subsets, 1, 2. These are all like subsets of this main set, isn't it? Right? That's why this, so if I name this B, so I'll just say, okay, B is a subset of A. If this is C, so C is a subset of A. So these are all called subsets, okay? Subsets, so smaller sets of a bigger given set. But wouldn't it be nice if we know, like, when a given, of course notation and all I'll discuss again, but wouldn't it be nice, like, okay, just write down the definition first, no? Some of you may be just waiting, say, no sir, definition, no, at least give us a definition. Write down a set A, okay? A set A is said to be a subset of, a set A is said to be the subset of set B if every element of A, if every element of A is also an element of B. If every element of A is also an element of B. Okay. And we write A is a subset of B. This is a notation that we use, like U, just in that form, no? Subset. So U, 1 equal to half equal to side. I'll talk about that, please don't worry. Just write down the notation now. So a set A is said to be a subset of the set B if every element of A is also an element of B. Finish? So, like for example, okay, one set B is given. So maybe a set A. So you can see, no, every element of A, B are elements of already B. So I can write A is a subset of B. I can write A is a subset of B. Right? That's what it means. Now going back, how many subsets can we make up? I have more to discuss on subsets plus, but before that, let's just study this. Dekho, A, B, C, AC, BC, AC, BC, AC, BC, AB. You see, These are all subsets, isn't it? Now, it would be nice, isn't it, actually, like how many subsets can we make in total? How many subsets can we have in total from any given set? So, like, if we get an idea about that, it would be really nice, isn't it? Because यहाँ कितना मिला 1, 2, 3, 4, 5, 6. We have got here 6 subsets. We've got here 6 subsets. So, how many more can we have? So, since I know, I'm going to tell you. You can have here 8 subsets. Okay, so what are the other 2? Right, what are the other 2? So that's really going to help us. So there's a small formula, small trick to that to find out how many subsets can I really draw from a given set, and that trick is actually given by, number of subsets will be actually given by 2 power n number of elements. 2 power number of elements in the set, in your given set. So यहाँ कितना हुआ? 2 power कितना elements है? 1, 2, 3. 2 power 3. So 2 power 3 कितना हुआ? 8 elements. So that's why I told you that there will be 8 elements. So for example, if you have like 4 elements, then 2 to the 4 to the 8 to the 16. So in that case, you'll have 16 elements. Likewise. Okay, likewise. So done, no? Written, no? This formula. Okay. So what are the other 2 sets? One universal fact there again. Always do remember that for every given set, the empty set and the set itself, the empty set and the set itself are also subsets of any given set. Now we are going to be discussing more about proper subsets. Now, what are these proper subsets? Why are they called proper subsets? Because they are proper, that's why. Right, because they are called proper subsets. So actually, what was the concept of subsets? Subsets is like, generally, the thing is like, okay, subsets is generally like a smaller set compared to the big set, compared to the mother set. Right, so when we denote like this, for example, this set, these are all subsets. So if I just name this set, let's say C, this is set B. So like this is a very small set, smaller set compared to the mother set. So like set C is going to be a proper set. This is going to be a proper set. This is going to be a proper set, a proper set, a proper set, proper subset, proper subset, proper subset, proper subset. As long as it is always smaller. That means, and how do we denote C proper subset of B? That means you get equal to sign nahi hoga na abhi yahan. That equal to sign will not come here. No, that equal to sign is not going to come here. Okay, that equal to sign will not come here. That's why it's called a proper set, a smaller set. This set, of course, if I name this as D, then of course D I can write as a subset of B, because this set D is also like equivalent to set B, isn't it? It's also equal to set B. So in that case, I can use this. Okay, so proper set generally means like a smaller set. Proper subset actually means a smaller set. Of course, you can write down a definition for that, like proper subset. Proper subset. You can just write down if A subset B, if A subset B and A not equal B. No, that's why I say no. A subset of B and A not equal to B. Then A is called a proper subset. It's called a proper subset of B. And we write a subset of B. Oh yeah? You can pause the button, note down, okay? Then that gives rise to one more set, that is power set. What is this power set? Even the name itself is so dangerous, isn't it? Kuch na kuch to power hoga, na? Please hold on, I'll have. Just think power set. What is the power set? Power power set. That means like it's like even the name is saying like it's a kuch to it should be of some like it should be having some kind of power. Yes, exactly. So power set. It's called a power set because listen, a power set is the set of all the subsets of a given set. I'll write it down. A power set is a set which consists of all the subsets. So remember, one of the sets that we took. What were the subsets? 1, 2, 3, 1, 3, 1, 2, 2, 3, null set, 1, 2, 3. These were the subsets. No? So the set of these subsets. So set of these subsets is called the power set. That means it's already now a big set, it's an umbrella of all the sets, all the subsets. So the set of all the subsets of a given set is called the power set. How do we denote? Suppose this set was A, so this will be like P, capital P for power, power set of set A, power set of the set A. Okay, so this is exactly actually equal to the number of subsets. That means number of elements in the power set of the set A of any given set will be denoted by 2 power number of elements in the set A. That's why it's 2 power 3, 8. No? Okay, note it down. Right. One more thing which I just want to tell you here is that, see, in the power set, these subsets will no longer be considered as sets anymore. Okay, this will be just considered as now ordinary elements or members. So the questions can be, how many elements are there in the power set A? So your answer will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when the sets or the subsets remain outside, okay, they are also called chalo hum bhi kuch hai, mulan bhi set, hum log bhi set hai. But when they come inside a power set, what happens? Like they just become like nothing, just some members only. Okay, so please be careful with that. All right. Okay, so that somehow sums up because interval, there's one more small topic left, like about intervals. Okay, this is not a very new topic, so you already know about this, but intervals. Now here, of course, about inequalities. You remember some of the inequalities that we've done in our lower classes? Greater than, less than, greater than or equal to, less than or equal to. When we're talking about these intervals only now, this is called strictly greater than, strictly less than. Not strictly, just greater than or equal to, less than or equal to. Right, these are the notations that we use. Now what does this mean? For example, if I say set of natural numbers, x belongs to natural numbers, and like x greater than, not greater than, less than 3. So what will be your answers? Less than 3 natural numbers, x belongs to natural numbers. Your answers will be like 1 and 2. I'm not going to be counting 3, isn't it? But if I say x natural numbers and x is, let's say, less than or equal to 5, then what will be natural numbers? Alright, 1, 2, 3, 4, and here, since it's greater than or equal to, I shall be including 5 also, isn't it? I shall be including 5 also. So there's a small topic based on these intervals which we are just going to discuss. I'm just going to give you a small topic, okay? So the first one will be like closed interval. I think my pastor is also tired, fell down. Interval. Closed interval. Now what do you mean by closed interval? We have open interval, we have half open, half closed intervals. No? Closed interval. Now this is generally represented by like this notation. Box. box bracket. Okay, now what does, so that's why now when you go for higher classes 11, 12, you have to be very careful with the brackets that you use also, especially in sets and when you try to represent intervals, because that can have a huge impact in the in what you are trying to represent. Okay, in what you're trying to represent. Now this would actually denote x such that, okay, x belongs to, let's just say, real numbers. No, I talked about real numbers, isn't it? Those who haven't, again, please go to that first video, go through quickly through that intro of real numbers and come back here. So x belongs to real numbers, then a to b closed interval means x hoga from a to b. From a, not after a and before b. It's from a to b. That means you will start counting from a to b. So if I just give you an interval 3, 5 and I say x such that x hoga natural numbers and x will be greater than or equal to 3, less than or equal to 5. So I shall write this in the roster form. What? Natural numbers greater than or equal to 3. So 3, 4, 5. No, from 3 to 5. Okay, got it? So that's what we call a closed interval. Milya came back. Okay. Then I will talk about open interval. Open interval. So open interval will be simply denoted by this round brackets, just round brackets, or sometimes it's called ulta bracket, like this. Notations are different, so you just have to understand the concept. And this means I'm just going to write here. Okay, I'm just going to write here, so please don't mind. That's going to be like open. That is like open. So that's going to be like be after a before b. Okay, after a before b. After a before b. So if I try to represent like 3, 5, again the same thing, such that x belongs to natural numbers, and so x will be like from after 3 before 5. So what will be our answer after 3 before 5? Answer will be in the roster form only 4, isn't it? It's going to be only 4, right? So that's called open interval, closed interval. So you have to be careful with this interval systems. And sometimes, of course, we will have half open, half closed. Let me just write like this. Natural numbers. This is like 3. This is like 5. Let's just going to discuss. So half open, half interval. So sometimes you might come across like 3, 5. So kya hua? 3 closed, 5 open. So what will be our answer here? Our answer here will be 3 closed, 3 natural numbers, no? 4, 5 to open, no? So I'm not going to be entering 5. Got that? We can even have 3 open, 5 closed. So 3 open ho gaya. So 3 open, 5 closed, 5 closed, 5 closed, 5 closed. So what will be our answer? 3 open. So that's going to be after 3 natural numbers, 4 up to 5. Okay, so these are the 4 types of intervals. Okay, we have this closed interval, we have this open interval, and then we have like half open, left hand open, right hand open. So don't be so confused about this. Just be careful about these brackets. This open means okay after this, but when this closed means like from to. Open means after, before. Okay, so this is going to wind up the third video on sets. So with this, of course, you can carry on with your exercises. I think at least up to the 3rd exercises you can easily carry on. Of course, definitely if there is a need, I will bring out videos on the solutions of sets of each and every exercise also. So if you have liked this video at the end, please do hit the like button, and of course please do subscribe and share it with maximum of the friends so that they will also benefit from this video. Thank you for being a part.